Okay, this is lesson 2.2, which is a 2-day lesson, but it covers conditional statements. So a lot of this is just copying. Just to keep the video short, I will skip through a lot of the copying, so you might want to pause it when you need to copy something down. Sorry, I already messed it up. Okay, so a conditional statement is a type of logical statement that has a hypothesis and conclusion. It's basically an if-then statement. It has an if and it has a then. So the if thing has to happen, then the second thing will happen. So the hypothesis is the part after if, and the conclusion is the part after then. So I'm going to write a sentence. You don't really need to write it down, and it won't make sense. Doesn't need to. If it is yellow, then it is happy. Doesn't really make sense, but I just need to show you this part. The hypothesis is the part after if but before then. So this right here, it is yellow. That's the hypothesis. The part after then is it is happy. That is our conclusion. So this whole sentence is what we call a conditional statement. This first thing has to happen before we know this happens. So the hardest part of this is putting it in if-then form. The best way to do it is to split it at the verb, and usually you can see what's happening. So this sentence is all panthers are cats. So if we split it here at the verb, first this happens, then this happens. First we have to know we have a panther, then we know it's a cat. So if an animal is a panther, then it is a cat. So a lot of people struggle with this, and I understand why, because sometimes I even have to look at it a long time. But the thing is, you have to say this exact thing without adding any new ideas. You can add words, like I can add the fact that I put an animal as a panther. But I can't say if all panthers are cats, then my name is Jack. That adds a completely new thought to it. So you still have to say exactly this, but you just say it with other words. So the sum of two odd integers is even. There's several different ways you can say that, but essentially, first you have two odd integers, then you know that their sum is even. So it's kind of confusing because sum's over here, but the even part is talking about their sum. So I would say if two integers are odd, then their sum is even. And I won't have you do this on the test. On a test, I'll give you the sentence in if-then form. But it's very important that you can see like what the hypothesis and conclusion are, even if it's not in if-then form. So this next part is about counterexamples, which is when you have a false statement and you want to prove it wrong. So I'll give you an example of that. You copy down this definition. You don't have to write the sentence though. Okay, so this part right here is our hypothesis, and this part that I'm circling is our conclusion. So if you live in Texas, then you live in Salina. That statement is false. But you can't say, because you live in Canada. That's not a good counterexample, because a counterexample makes this hypothesis true, but the conclusion false. So I need a place that you can live in Texas, but it's not Salina. This part needs to be false. So a good counterexample could be that you live in Frisco or McKinney or any city in Texas that's not Salina. You also can't say something like you live in Salina, Ohio, because that doesn't make this part true. You have to live in Texas. All right, so these are sentences that are not in if-then form, and you need to pick out the hypothesis and conclusion. So hypothesis would be the first part that happens. The conclusion would be the second thing that happens. So K is the midpoint of JL if JK equals JL. So the part after if is the hypothesis. So if this was an if-then form, it would say if JK equals KL, then K is the midpoint of JL. N is greater than 8 if N is greater than 7. So if N is greater than 7, then N is greater than 8. Why don't you pause it and see if you can do the last two. Mr. Scroggins sings when all his students get an A on the test. So first, all his students have to get an A on the test, then Mr. Scroggins sings. People who live in Texas live in the United States. People who live in Texas live in the United States. So it's like if you live in Texas, then you live in the United States. So this one wants a counterexample. So if Rachel is 16 years old, then she has obtained her driver's license. So this is the hypothesis. This is the conclusion. So for a counterexample to work, this part has to be true, this part has to be false. So we can say Rachel is 16, but she doesn't have her driver's license. So you just think of a reason why Rachel might be 16 and still not have her driver's license. You could put that she failed the test. You could put that she didn't get her permit in time. Or maybe her parents just don't trust her on the road. If a number is divisible by 4, then it is divisible by 6. So you need a number that is divisible by 4 and not divisible by 6. So 4 would work, 8 would work, 20 would work, any of those would work. 12 wouldn't work because it's divisible by 6, so you need that part to be false. You couldn't say 30 because that's not divisible by 6 or by 4. So it has to be divisible by 4, but not divisible by 6. All right, negation is when you use the word not, but I like to think of it as the complete opposite of a statement, because if I say this shirt is not blue, the opposite of that would not be this shirt is not blue, because you don't use double negatives. So it's kind of like adding the word not a lot of the time, but sometimes you take out the word not. The complete opposite of me saying this floor is tile is to say this floor is not tile. You don't say this floor is carpet, because that's not the complete opposite. Because it could be carpet, could be hardwood, could be a lot of things. All right, so this is the bulk part of this lesson. So our conditional statement is our if-then statement. We can say if P then Q. We represent it with symbols like this. So here's an example. If it is a rose, then it is a flower. So our converse flips the hypothesis and conclusion. So I call those our flips. So you just switch these two things, if Q then P. So that sentence would look like, would look like this. If it is a flower, then it is a rose. We just switch these two. Our inverse is when we go back to the first equation and we negate it. If not P, then not Q. And this little symbol means negation. So if it is not a rose, then it is not a flower. The contrapositive is when we do both. We flip it and negate it. So if it is not a flower, then it is not a rose. And you may need to pause it so you can get time to copy that. So the conditional and contrapositive are related, and the inverse and converse are related. So if one of these is true, the other one is true. If one's false, the other's false. So you'll never have 3 true and 1 false or something like that. You would either have 2 of each, or they would all be true or all be false. So let's look at these. If it is a if it is a rose, then it is a flower. Well, since a rose is a flower, that is true. If it is a flower, then it is a rose. This one is false because it could be a dandelion. This one says if it is not a rose, then it is not a flower. Also false because it could be a tulip or a dandelion. If it is not a flower, then it is not a rose. That's true. If you don't have a flower, there's no way you could have a rose. So notice the top and bottom The conditional and contrapositive are the same, and the converse and the inverse are the same. That's exactly what this says. All right, so every Friday we have a pep rally. So split it right here. Let's write that in if-then form. First has to be Friday, then we know we have a pep rally. So if today is Friday, then we have a pep rally. Now we decided that was false because, for example, last week we had one on a Thursday. The converse, you'll flip-flop those. If we have a pep rally, then today is Friday. That is also false. We had one on Thursday last week, but we don't even have them all year long. So this one, a Friday in May won't have a pep rally. The inverse is where we put not in. So if today is not Friday, then we do not have a pep rally. Also false, because you could have it on a different day. The contrapositive is when you flip it and negate it. So if we don't have a pep rally, then today is not Friday. That is false. And again, if you need time to write that, you'll pause the video. So I'd like you to pause it and see if you can do this one all by yourself. And then I'm just going to uncover them quickly. So all Texans live in the United States. So if you are a Texan, then you live in the United States. That is true. And we're just assuming a Texan is someone who lives in Texas. So if you were born in Texas and then moved away, sorry, you're no longer a Texan. Because by definition, a Texan lives in Texas. So the converse where we flip that would be if you live in the United States, then you are a Texan. And that is false because you could be a Floridian if you're from Florida. Inverse, we just add not. If you are not a Texan, then you do not live in the United States. That is also false. Contrapositive, you flip and negate. So if you do not live in the United States, then you are not a Texan. That is true. If you don't live in the United States, there's no way you live in Texas. Okay, so if a conditional and its converse are both true, we can write a biconditional. So you take off the if and you take off the then and you separate it with this phrase, if and only if. So tell whether each statement is true or false, then write its converse and tell if it's true or false. So if x squared equals 9, then x equals -3. This is false because x could equal +3. We don't know. The inverse of that is if x equals -3, then x squared equals 9. And that is true. So that one you couldn't write a biconditional for because they're not both true. If the measure of angle A is if the measure of angle A is 60, then angle A is not obtuse. That is true. If angle A is not obtuse, then the measure of angle A equals 60. That one is false because it could equal anything below 90. So like a good counterexample would be like 20. That's not obtuse, but it's not 60. So this part is the same directions. I need to get these tools up here. So if Beth lives in Dallas, then she lives in Texas. That is true. So the converse of that, remember, you'd flip the hypothesis and conclusion. So if this is the conclusion right here, she lives in Texas. This is the hypothesis, Beth lives in Dallas. Now the thing is, you want your sentences to make sense. So we wouldn't say if she lives in Texas, then Beth lives in Dallas, because you always say her name before you say she. So you would say if Beth lives in Texas, then, sorry, my thing messed up. Then she lives in Dallas. And this part is false. So a good counterexample to that would be that she could live in Austin or Salina or anything other than Dallas, but it does have to be something in Texas. So if A is greater than 2, then 3 times A would have to be bigger than 6. That's true. Any number that's bigger than 2, when you multiply it by 3, it'll definitely be bigger than 6. So the converse of that would be if 3A is greater than 6, then A is greater than 2. Now always remember to capitalize the beginning of a sentence and put punctuation. I know it doesn't seem like a big deal, but you're in high school now and that should just be second nature. This one is also true. If 3 times a number is bigger than 6, then that number has to be bigger than 2. Okay, so here we have the conditional. If 2 angles are supplementary, then the sum of their measures is 180. That is true. The converse of that would be if the sum of the measures of 2 angles is 180, then they are supplementary. That is also true. So this is what we were talking about with the biconditional. You can write it as long as the conditional and the converse are both true. And it always works with a definition. Like this is the definition of supplementary. So both things have to be happening. You have to have 2 angles adding to 180. And that means they're supplementary. So what you do is you take out the if, take out the then, and between them you write the if and only if. Now I'm going to rewrite it, but it's that simple, and I have a lot of people miss this because they put if and only if like at the beginning or something crazy, but you can just take out the if and then and put it right in the middle of the hypothesis and conclusion. So you would say, notice I capitalized the T because it's now the beginning of my sentence. 2 angles are supplementary if and only if the sum oh, sorry, my pen messed up. Is 180 degrees. Period. Now you could also write it the other way, like the sum of their measures is 180 if and only if the 2 angles are supplementary, but it's just as easy to do it that way. All right, rewrite these as a biconditional. So I'm not going to spend a whole lot of time rewriting these. I'm just going to show you what you would do. You would cross out the if, cross out the then. You don't forget to capitalize the beginning of your sentence, but then right here you would write if and only if. So that sentence would be a polygon is equiangular if and only if the angles are congruent. This one, cross out the if, cross out the then, capitalize the beginning of a sentence. An angle is obtuse if and only if its measure is greater than 90 and less than 180. So I'll actually write them out so you can see what they look like, but if you think you've got it from there, you can fast forward through this. Okay, so I know it's a lot of writing. That's why I was showing you the quick way to do it. But on your test, I'll just have you write 1. So it's not going to be a whole lot of writing on the test. So just make sure that you remember how to do it. The if and only if is the big part there.